Welcome to the Charleston Housing Analysis and Predictions website. The point of the website is to run an analysis on some raw Charleston housing data and perform prediction in the form of price predictions based on infrastructure changes that are happening in the area within the next 5 to 10 years. First, we will start by running an analysis. We will select the price analysis. On this site, you can see the analysis of the correlating variables between mean sales price and the other features of the model. The feature that has the largest direct correlation is the household income range, and the feature that has the largest inverse correlation is the number of current residents, which means that the mean sales price increases with the household income range being higher and the number of current residents being low. We've removed the Kiowa Island data because Kiowa Island has the highest mean price of all the towns and cities in the data set. The feature that has, once we remove it, the feature that has the largest direct correlation still is the household income range. But the feature with the largest inverse correlation becomes the infrastructure rating. Go back to the beginning and run an analysis for all the variables. And you can see when we run this analysis that the features that are most directly correlated are mean square price and household income range with a score of 0.878. And the features that are most inversely correlated are the number of current residents and the proximity to workplace, the score of negative 0.559. The number of current residents and proximity to workplace are more than likely inversely correlated due to the fact that the number of current residents would be low in areas that are close to the workplaces that were selected, since the workplaces are typically industrial areas where the residents are not very high. The highest correlating factors for the entire model are infrastructure rating directly and school ratings indirectly. We'll go back to the beginning of the website now, and we will run into the prediction section. We'll first start by clicking below for the regression analysis to check the proper fitting. This takes a second to load, so patience will be needed because the regressions are all running in the background. When the site loads, you can see that the started with the linear regression of the data split into training and testing sets. The results of this regression are an R-squared value of 0.991, which is very good. But we will still perform regularization and check the results again using a lasso method. We use the lasso method because the model shrinks the less important coefficients to zero. Although there aren't a lot of coefficients in this, there are a few non-important ones. We find that the R-squared value becomes 0.996, which does show an improvement. We run it against fivefold, with the lambda being 0.1 times 10 to the negative 5. And we can see that there is a performance improvement with the two of the fivefolds. We've checked the coefficients using the cross-validation of the data set of that best alpha that we found, and we perform a grid search cross-validation to get the grid score and the grid estimator. All of this finds that the model is good and will work well for predictions. So we'll move into the prediction area. First, we'll start with Charleston as the town for the prediction, and we'll select the North Meeting Street I-26 exits. We'll click Predict. We can find that using the lasso method, the mean sales price is predicted to change from 277K to 361K in 2019. We'll run the prediction again with all towns and none of the infrastructure, And we can see that for all the towns and none of the infrastructure improvements, that the mean sale price is predicted to change from 491K to 512K in 2018. If we go back and run the final check, we'll run the Mount Pleasant against the Highway 41 widening and bridge improvements, and we can see that the mean sales price is predicted to change from 380K to 445K in 2020, which is when that highway widening is expected to complete. If we go back to the beginning and click on View Raw Data, you can see that this is the raw data that was used for the entire model and the categories that are in each. Now we'll go over to the repo and we will select the flaskapp.py, which is the base code that runs the model. We will scroll down to the analysis section. This analysis section takes in that information from the website, the analysis type, whether it's infrastructure, price, or all the variables. If it is one of the infrastructures or price, the model runs through the SynCore, which is the correlation information, and returns the table in the data frame, as well as the max and min values. The model then reruns the section after the Kiowa Island is removed and shows the correlation factors as well. Then it prints those answers to the website. It does this again when the item is for all the variables. The next section is the regression section that we'll go through. The regression section takes the data in, gets dummy variables, and splits the data into the training and testing variables. We'll scroll up and we'll take a look at that. Here is the area where the data is segregated into dummy variables. And here is the area where the data is split into testing and training, as well as scaled. We go back to the regression, and we can see that the model then runs the linear regression on those testing and training models data, and that area of the code is right here where the linear regression is selected, it is fit, and the testing and training is compiled. We get the R-squared score and returns the coefficients along with the linear regression scatter plots. We go back to linear regression. We can see that the next step is to check the lasso method against the versus the linear regression. We run the lasso to find the best R-squared as well as the best alpha value. And in that area, we can see that the regression is lasso, the errors are collected, the alpha is optimized, and the regression is run with the optimum alpha, and the cross-validation score is calculated. The next part of the regression is to check which was better, the lasso method or the linear regression method. Once we have that selected, we run the cross-validation and the grid search cross-validation to get the coefficients and the grid score and grid estimator. Go look at those code areas. We can see that the grid search code runs the grid search with the model, which is a lasso model, and the cross-validation area, which runs the cross-validation and returns coefficients based on that best alpha. The next part of the code is the actual prediction section of the code. The prediction section takes in the town and the infrastructure request from the user on the website. It splits the data and runs the linear regression and the lasso regression to see which performs better. And then it sends the data, sends the town selected, the infrastructure update, and the data set to the price prediction section of the code. The price prediction section of the code takes in the data, checks the infrastructure section, and makes improvements to the data based on the infrastructure improvement. For example, the North Meeting Street exits that we ran first gets the year 2019, which is the expected year for completion, has the affected towns, Charleston and North Charleston, the proximity to workplace improvement of 0.02, and the infrastructure improvements of 0.02 for Charleston and 0.05 for North Charleston. That data is collected and it's concatenated to the data that's already in the model, is scaled, and then returned to the prediction section. In the prediction section, the model then gets the information and runs the analysis whether the lasso method is preferred over linear regression. It runs the lasso and then fits the model and then runs the prediction and then returns the data to the website with the current values versus the predicted values. And that is how the prediction method works. Thank you.